For question number 1, you have to create a series of 3 screenshots illustrating the idea that as the sample size increases, the t-distribution will get closer and closer to the standard normal. In order to do that, in each screenshot you want to specify a two-tail probability in the upper left corner and set the cutoff for the right tail at 1.96. The thing that you're going to vary is the degrees of freedom. In the first screenshot, you want the degrees of freedom to be less than or equal to 20. Second one, between 40 and 70. Third one, at least 150. If this is worth 3 points, it's 1 point for each screenshot. To construct those screenshots, the correct option that you want in StatKey is a t-distribution under theoretical distributions. So it'll be a sequence of 3 t-distribution graphs. This is what your screenshots should look like. That part in the wording about don't crop out the degrees of freedom, that's visible in the upper right in my screenshot, that box. Make sure that's there because without that it's impossible to tell what your degrees of freedom are. So you need that box and you need the graph. If you notice what's going on in my graph, I have 2 tails selected in the upper left corner. I have the 1.96 as the right tail cutoff, and I've got my degrees of freedom visible, which is one that you really can't use because it's not less than or equal to 20 and it's less than 40. The other thing that I want to point out here is the proportion in the center of my graph, the 0.941. What should happen in your sequence of graphs is that the central proportion should get bigger. Not only should it get bigger, but it's also going to get closer to 0.95. That's what's supposed to happen, so if that's the way that it's working out, everything's probably set up correctly. Question number 2 talks about a confidence interval, but you don't have enough information to actually compute one. You don't have an X bar and you don't have an S, but you can come up with a critical value, and that's all you have to do here. That's worth 1 point. It's half a point for the correct degrees of freedom and half a point for the correct proportion in the central region. So that's all you really need is a screenshot of the critical value, and again, make sure you don't crop out the degrees of freedom box. Question number 3 is a desired sample size computation. This is one where you don't have a previous study to work with. There's no X bar and there's no S there, but you do have a max and min in the last sentence of text, so there's a way that you can get the range, and that's what you can work with here. That's worth 2 points. It's half a point for having the correct desired sample size formula and substitution other than the sigma tilde, half a point for the correct sigma tilde, half a point for correct simplification, and half a point for rounding up to the next integer. I think it's a good idea to show work with this question. If you show the work that I have in the desired sample size calculations in the 6.4 through 6.6 notes, I think you'll be fine. That's enough, and I think that's really what you want to have here just to be safe. Because of the histogram, question number 4 is kind of long on the page. So here's the first part with the histogram there, which isn't perfectly symmetric, but it's symmetric enough. That's not something that's heavily skewed, and it's certainly got one peak and it doesn't have any outliers. Parts A and B combined are worth 3 points. Part A is worth half of a point and part B is worth 2.5. For part A, if your answer is the sample size is too small, that's not enough. Yes, the sample size is too small for something. It's only 19, and that's not big enough. The important thing is, what is it too small for? In other words, what can you not do because the sample size isn't big enough? There are a couple of different ways that you can phrase that, but that's what needs to go in there. Part B, constructing the confidence interval, 2.5 points total. It's 1 point for the critical value, so you'll have to have that screenshot with the degrees of freedom box visible. That 1 point will break down to half a point for the correct degrees of freedom and half a point for the correct proportion in the central region of the graph. The rest of the points there, half a point for the correct point estimate, half a point for the correct standard error, and then half a point for the correct simplification / endpoints. Number 5, which is a hypothesis test, this is worth 6 points total. It's half a point for part A, 2 points for part B, 1.5 points for part C, and 2 points for part D. Part A, the half point, why don't we need to check the histogram of the sample this time? Kind of like with 4A, saying the sample size is large enough isn't going to be enough of an answer. If you want to phrase it that way, the sample size is large enough to, and then fill in the blank at the end of that sentence, that works. So yes, the sample size is large enough, but large enough to do what? That's the answer for A. B, the hypotheses, that's 2 points, half a point for the correct parameter, half a point for the correct constant term, half a point for the correct inequality in the alternative hypothesis, and then I guess half a point for having the equals in the null. Part C, computing the test statistic. If that's 1.5 points, it's half a point for the correct numerator, half a point for the correct denominator, and half a point for simplification. Part D, if that's worth 2 points, it's half a point for the correct degrees of freedom, half a point for the correct cutoff, half a point for the correct tail, and then half a point for either doubling or not doubling the tail, whichever one you're supposed to do there.